Okay, without wasting any more time, we will have our next and final speaker for this evening. Uh, he brings 20 years of experience across data engineering, IoT, RPA integration, and now AI-driven systems. He's currently working as a senior software architect at Quantiphi. Can we please have Nirav on the stage and a huge round of applause for him?
Good evening, everyone. Am I audible? At the back? Okay. So, here is what, I would say call myself as. Basically, I'm a GDE in Google Cloud platform category, specializing in data and analytics, working for a company called Quantify, and working as a senior technical architect there. I started my journey way back when some of you were not even born. It's like more than 21 years now. But this particular talk, I've given talks multiple places, multiple cities, multiple countries, and must be more than 50 talks I've given. But this particular talk is very special for me. Two reasons. One, I'm basically a Gujarati, and this first time I'm giving this talk or any talk on the land of Gujarat. So thank you, organizers, for giving me this opportunity. And second reason why this is so special is because my wife is sitting next to me. She's joining me for the first time, and she was curious. तुम यार ये हमेशा टॉक देने जाते हो, करते क्या हो, मुझे देखना है. बोला आ जाओ मेरे साथ, देखते हैं आज. Okay, anyways, jokes apart. So today I'm going to talk about very difficult topic. And you must be having, this is not working. Somebody. Check. It's not working. Check. Okay. So, well, even though I understand that these topics are a little bit difficult, but I'm going to make it very simple for you. And I'm sure at this moment, when I'm just starting my talk, you must be having the same expression as the smiley has. By looking at these words, database, data warehouse, data analytics. And I think, I remember one of the question was about data warehouse. That, what is the data warehouse service in Google Cloud? So you're going to get the answer in this session. So be attentive. Okay. So I'm also going to talk about few other words, keywords, which you might, might feel that this I have heard somewhere, but I don't know what is it. So you might get some clarity about that today. Okay. Moving on. So I'm not going to throw so many jargons here, okay? But try and put yourself into the shoes of someone who's like a data analyst or maybe a data engineer, okay? Think of yourself as a data engineer. And this is a, a kind of circumstance or a situation has been given to you. That, I have some application. That application is like, mobile application or a web application. And I have a backend server, okay? Now the question is, I want to store data from this server into something in my storage layer. What system will you use? Can anyone answer this? No one has answer. I understand it's 5 o'clock in the evening, but guys, thoda to answer de do. No, it's not data lake, but ये database से है. Basically, application से जो भी data आएगा, server के through, I will store it in database. बंद हो जाता है. अच्छा. So I'll store it in database. Okay. Database क्या होता है पता है ना? Tables होते हैं, जो columns होता है. I don't know why am I speaking in Hindi. I think most of you are Gujarati, right? अरे perfect. So आपने बताया खबर ऐसे database, tables. अरे why are you laughing यार? I am taking pride in speaking in Gujarati यार. Okay. So वही tables, rows, columns, वही होता है database, right? हम लोग बहुत जगह पर बोलते हैं कि अरे फलाना कंपनी के पास डेटाबेस है, उसके अंदर मेरा एंट्री आ गया, मेरा फोन नंबर आ गया. बट वो डेटाबेस क्या होता है? वो ये डेटाबेस होता है, तुम लोगों ने सुना होगा, माई सीक्वल, ऑरेकल, सीक्वल सर्वर, दोज आर ऑल डेटाबेसेस. अभी दिस इज ऑल फाइन एंड मोस्ट ऑफ द ऑर्गेनाइजेशन यूज दिस. ओके, नाउ लेट्स गो वन लेवल बियॉन्ड. उसके पहले एक बार समझ लो कि डेटाबेस कहां यूज होता है. यू हैव सम ट्रांजैक्शनल डेटा, यू आर कंटिन्यूसली अपडेटिंग द डेटा. फॉर एग्जांपल, तुमने एक आईआरसीटीसी, ओके, आईआरसीटीसी एप्लीकेशन, तुमने टिकट बुक किया, उसके डेटाबेस में चला गया, so and so person has booked a ticket for so and so date, so and so train, right? 2 मिनट के बाद में तुमने टिकट कैंसिल कर दिया, तो उसको टेबल में से एंट्री डिलीट करना पड़ेगा, राइट? सो यू आर एडिंग डेटा, you are deleting data, sometimes you might want to edit also data, right? And all of that is possible only with databases. Here you keep data much like normalized. Engineering में बधाई बढ़ियों से, right? के normalized data, reduces the size of the data, but it becomes little difficult when you want to query it, right? But that is how we do it in databases. But the problem with this is, like, it can store data from one source only. You generally don't try to store, for example, Amazon का data भी वहां पर आया, कोई और वेबसाइट का डेटा भी एक ही डेटाबेस में आया, ऐसा नहीं होता. We'll store from one source, one application, and there is no analytics. Analytics मतलब, if I want to know कि कौन से रीजन से मुझे मैक्सिमम ऑर्डर्स मिल रहे हैं, या फिर कौन सा प्रोडक्ट ऐसा है which is most running, those questions are generally called analytics. And for that, or say for example, I want to do, like, 12 month का मुझे ट्रांजैक्शंस चेक करना है, सेल्स चेक करना है कि मेरा सेल्स अप जा रहा है, डाउन जा रहा है. All of that is called analytics, and that cannot be done with databases. So now you understand the scope of database, where to use database and where not to use. Moving on. दूसरा scenario. Consider that you have multiple applications. Each application through their servers writing to their own respective databases. Now you tell me, what do I do? सब अपने अपने डेटाबेस में गए, सबका डेटा अपने अपने डेटाबेस में. नाउ यू वांट टू क्वेरी और डू एनालिटिक्स व्हिच इज स्पैनिंग अक्रॉस डेटाबेस. भाई ये एम्प्लॉई का डेटा कितनी बार, हाउ मेनी, व्हाट इज द अटेंडेंस ऑफ दैट पर्सन, और मे बी what is the spend he is doing. And if these two data, you are having it in two different database, what would you do? You cannot fire query to one database, right? For that, you need to collect all the data in one place, and that one place is called data warehouse. So you collect data from multiple databases and store it into data warehouse. But there is a specialized process used in between, which is called ETL, which means extract from database, transform it, and then load it into data warehouse. So it's called ETL. Okay, it's a very common terminology, and maximum people use this for all their analytics purpose. This is the first step, ETL. Okay, once you store your data in data warehouse, then you can create all your dashboards for BI analytics. And this is what is called analytics, BI, specifically BI analytics. Now, you see two different worlds here. Whatever you are seeing up to databases, that's called transactional world. Whereas, or after the databases, I mean extracting from databases, storing into data warehouse, doing analytics on top of that is all called analytical world. Now you need to understand these concepts well. What is transactional world and what is analytical world? And most importantly, you use databases for transactional data and you use data warehouse for analytical world. The some basics about data warehouse: it stores data from multiple data sources. It has whereas in database you had a normalized data warehouse you try to flatten your data so that you can query it quickly. You can only store structured data. What do you mean by structured data? Does anyone know? Structured? No. So everything, tables, rows, columns is called structured. Okay. But in case if you have your data, let's say as image or video or say XML, they are basically unstructured data, right? Sometimes it is semi-structured data. Generally JSON and XMLs are also called semi-structured, which is in between these two. So data warehouse, you use it only for structured data. Why do you use data warehouse? You use it for these purposes. You want to do sales report or financial analysis or performance analysis of the system, or for example some trend analysis. All of that, for all these scenarios you use data warehouses. The good part with data warehouse is that it will not let you store any junk data. It will say that if you want to store any data in data warehouse, it has to be in the right format, the right column, data type, whatever whatever columns you have, only that data you can store. So schema of the data is automatically applied when you store data into data warehouse. But the problem is it does not have a provision to store unstructured data. But today, with development of AI, lot of organizations are now wanting to store their image data, maybe live dash cam videos, etc. Lot of unstructured data is getting ingested these days, and that's where data warehouse will not be used. So there comes another requirement, that I have a lot of unstructured data with me. How do I process it? That's a next question for the organization, and hence this is the new invention. Of course, it is not new. It happened in 2014, but a next generation you can think of. Your transactional world still remains same, but on the analytical side, instead of storing it into data warehouse, now I'm storing it in data lake. Now it's a new term for you, but data lake, you think of it like it allows you to store all types of data, be it structured or unstructured. Even if the data is video or image, it will allow you to store. So you might have thought, you must be knowing Amazon S3 or maybe Google's cloud storage. All of that are basically, you can consider it like a data lake. Okay. It also allows you, if your data is streaming, it allows you to store that data as well. But the problem is, BI analytics I cannot do on that. The graphs, the charts that I wanted to see, that I cannot do it on data lakes. And hence, but what I can do with data lake, I'm not only storing it, I can do advanced analytics. When I say advanced analytics, it necessarily means, let's say I want to build some ML model or AI use case on top of my, structured and unstructured data. I can do it very well with data lake, because all the integrations, the connectors that we have generally, that supports data lake very well. And hence, data lake is ideal for advanced analytics, whereas data warehouse was good for BI analytics, dashboards, reporting. So now that's again a problem for organizations, that while I am able to do advanced analytics, I'm not able to do uh, the BI analytics. And hence, they came up with a solution that let us have a combination of two. And this is how it is. They store all the data into data lake first. So that becomes your landing layer. Everything comes to data lake first, be it structured or unstructured. But from there, whatever meaningful data I want for my BI analytics, I extract it using ETL, store it into data warehouse, and then I apply dashboard on top of that, reporting on top of that. Which means now I'm able to do advanced analytics as well as the BI analytics, which is dashboards. Now, that solves all my problem, right? But definitely it comes at a cost, increased cost, because you need to implement two different systems. And when you say two different systems, other set of challenges also come. You need to keep them, in consistency. If I store my data in data lake but not in data warehouse, then probably I might not get the complete picture, the right picture. And hence, those are different set of challenges again. So there was always a challenge and there was a requirement to solve this problem, that while I want to support advanced analytics as well as BI analytics, but I don't want these challenges of increased cost as well as increased problems related to consistency. And hence, there was a new invention, and that's called Lakehouse architecture. Now, this is again definitely a new term for you guys, but think of it like, you are still storing your data into data lake. Now, when I say data lake, think of it like your folder, okay? In your folder, you just dump all your files. But on top of that, there is a management layer called metadata and governance layer. What does it do is basically, while your data is still not in the table, it is still in the format of files, that management layer will interpret that files as a table, which will make my data lake act like a data warehouse. So you have data lake, on top of that I have an interpretation layer, management layer, that will turn my data lake into data warehouse. And hence what will happen is, I can support all my analytics queries, BI analytics, advanced analytics, all of that, ML use cases, AI use cases, all of that from the single system. And that single system is called Lakehouse. Clear? The advantage with this is, you get the advantages of both data lake as well as data warehouse. Okay, moving on. Now, many clouds these days, when you talk about Google Cloud, it comes with this feature. It allows you to build Lakehouse using the inbuilt services. So I'll tell you why. The advantage with Lakehouse is that, you have single system for all your, there's no two system, data warehouse, data lake. They are not two different systems. That's only one system. And you can do all your ingestion, integration, storage, governance, analytics, everything from one system. You have single system to deal with for structured as well as unstructured data. You can do batch as well as streaming processing from the single system. Earlier, you had to have two different systems. And moreover, for developers, you can use all your Python, SQL, notebooks, IDEs, everything. So you have all the flexibility. Everything can be done from the single system, and that's called Lakehouse. Now, how do you build a Lakehouse using Google Cloud? You don't have to do much, nothing. You just store all your data in either Google Cloud Storage or in BigQuery. They allow you to give all the features of Lakehouse on top of that. It will allow you to query your data in SQL as well as Python, Spark, whatever you say. On the right hand side, you can query your data using SQL, Python, anything. On the left hand side, you can store data from all your sources, being structured, unstructured, be it real time or batch, anything. Okay. So they have made Google Cloud Storage and BigQuery in such a way that all sorts of analytics requirements can be served from these two systems. But generally, what people do is, in Google Cloud Storage, they store all their unstructured data and they store their structured data, tabular data, into BigQuery. Now, somebody may say that, what if I have some structured data as a file, CSV file, Excel file? You can still store it in Cloud Storage bucket. But on top of that, you can do the SQL query. And that is the compatibility that Google has developed. And hence, we are calling it as Lakehouse in Google Cloud. Okay, now we know that, if I store my data in Google Cloud Storage and BigQuery, that is building all my Lakehouse. But generally, when you talk, when you speak to any organization, generally they don't dump everything into one cloud storage. They have some kind of organization while storing their data, right? Generally, it is called medallion architecture, which says that you organize your data storage in 3 layers. These 3 layers are called raw layer, enriched layer, and curated layer. Now, this is again, it's just a fancy word. Behind the scene, they are still Google Cloud Storage and BigQuery only. Okay, but raw is that zone of your data where you store all your raw data from all your source systems. You store it in as is format. The way you had it in your transaction system, you store it the same way. The second layer is that data might have certain data consistency problems, quality issues, etc. Right? Some junk characters, some null characters. You might want to clean that data before using it. And for that, what you do is you do certain processing, you clean that data and store it in enriched layer. Now, this is again same type of storage, just a different compartment or a different data set where you would store it. And finally, the curated layer is the one where your dashboards will pull data from. So you have laid down all your data in such a way that dashboards can directly pick it up and easily populate your dashboards quickly and with least cost. So you prepare your data in that manner and store it in curated layer. And so I am still saying that, all your storage layer is still BigQuery and Google Cloud Storage, but I have tried to split it into 3 different layers. Now, to do so, to move data from one layer to other, you might need to do some kind of ETL processing, and that is what we call it as processing layer. And you can use all the services that I have mentioned here to do that data movement from one layer to other. Generally, people use BigQuery SQL, but otherwise also you want to use Dataflow, Dataproc, Cloud Function, you are free to use that. Now, think of it this way, that this is like one team in your organization that splits your data into these 3 layers. At the same time, they may have to work with various codes, SQL file, maybe Python file, Spark code, etc. They may have to deal with your infrastructure like pipeline, Kubernetes, or whatever infrastructure you need. You might have to work on that as well if you are one team working on this particular use case. At the same time, you might have to look into logs for debugging and all of that. You may have to apply certain security policies, etc., so that the right person can only access it. And plus, you will also need to create a catalog of all your data. If you have a lot of data, you do want to know that what data is what. You need to maintain a catalog of the data. Now, Google Cloud says that we have all these services in their portfolio that lets you deal with all these functions that includes security, managing of your data, logging, debugging, storage, code, everything. This is what this hexagon, what you see, is everything that a team, a data engineer needs to handle. Now, now we have talked about you can use all this service to build your lake house, right? Now, what is data mesh? I'll just quickly take 2 minutes and I'll wind up my session. Uh, so, what is data mesh? Let's say, guys, please, let's say you are working in an organization which is huge, some aviation industry, maybe some automobile industry, okay? I work for such kind of companies and I'm telling you the real world examples of that. They may have multiple teams. Like for example, aviation industry might have, one department for cargo, one department for ticket reservation, one for, maintaining reservation and maybe some hotel and some kind of booking and all that, right? Some loyalty programs, etc. Every team has their own implementation. They will pull data from 10 different sources, store it in one place, and maybe their dashboards would different. And no department has any connection. Everyone is working in their independent way, right? Now, if let's say you are working in that scenario, every team is developing their own lake house. How will you ensure that, everyone is following the right practice, right security practices, right governance strategies, right quality insurance? How would they do it? And that's where you need something called as data mesh architecture, where that principle says that you give, all the ownership to their respective teams. They are all handling their own respective, data infrastructure, etc. But you can still control the security policies, etc. from centrally. Okay, there'll be one central team who would give the guidelines, but all the unique teams will be working in their own independent way. That is what is called as data mesh architecture. Google Cloud has a specialized service called Dataplex that lets you build this governance framework for data mesh architecture. I don't want to get too much into depth. I know it's 5 o'clock and probably maybe next time sometime, but that's all I wanted to talk about. And that's my handle. In case if you want to connect with me on LinkedIn, I'll be happy to help. Thank you so much.